Welcome back to my YouTube channel, The Exploring Medic. So we are continuing the series of mechanics of pulmonary ventilation of the respiratory system. And in case of any doubt, you can ask in the comment section. Feel free to ask your doubt. And today's topic is little bit basics of the respiratory cycles. So try to recall it, try to understand it. And in case of doubt, even you can ask in the comment box, or you can give any kind of suggestions too. Okay, so let's start the topic. Pressure and volume changes during respiratory cycle, that is intrapulmonary pressure changes during respiratory cycle. So first we will discuss intrapulmonary changes during respiratory cycle. The movement of air in and out of the lungs, that is inspiration and expiration both, depends primarily on the pressure gradient between the alveoli and atmosphere, that is trans airway pressure. Why? Because movement of air, that is inspiration expiration, depends upon alveoli as well as atmosphere, because both levels should not be same. One time if the alveoli level is decreased, intrapulmonary pressure, then the atmospheric pressure, then air will enter. When the intrapulmonary pressure will increase, then the atmospheric pressure, air will be released. So both have the sequential combination mechanism, that is trans airway pressure. Intrapulmonary or alveolar pressure is the air pressure inside the lung alveoli. So it depends upon intrapulmonary pressure. Now, at end expiration and at end inspiration, means when there is process of going to start inspiration and when there is process to going to start expiration, that is when the glottis is open and there is no movement of air. Because glottis is open, so there will be no movement of air, and the pressure in all parts of the respiratory tree are equal to atmospheric pressure. So pressure inside the lungs and pressure of the atmospheric pressure both are same. Hence the intrapulmonary pressure is considered to be 0 mm of Hg. So at that time intrapulmonary pressure, it is IP is 0, because both the pressure are same due to opening of glottis. Now during inspiration, that is quiet breathing, that is tidal respiration or normal respiration, you can say anything, the pressure in the alveoli decreases about minus 1 mm Hg, that is decreasing the pressure, which is sufficient to suck in about 500 ml of air in the lungs within 2 seconds of inspiration. So when there is decrease in minus 1 Hg, approximately 5 ml of air is sucked inside the lungs during the process of inspiration, and at the end inspiration, the intrapulmonary pressure again becomes 0. As we have seen here that the end expiration glottis is open and again it becomes 0. So this we can understand by the graph given here. This is lungs. Now during inspiration, that is tidal volume, that is normal respiration. Now when it is starting, you can see that it is starting from 0 and going to 500, and again at the end of inspiration it will take back to the 0. So this is the process where it leads to the 500 and then again it goes to 0. So this was minus 1, and this occurs when there is minus 1 mm Hg changes in the inspiration. So during minus 1 mm Hg, it becomes 500 to 0. Now during forced inspiration, against the closed glottis, that is Mulliver's maneuver, the intrapulmonary pressure may be as low as minus 80 mm Hg below the atmospheric pressure. So when there is a forced inspiration, at that time your intrapulmonary pressure can go to minus 80 mm Hg. You can see where is minus 1 mm Hg during the normal inspiration, and when there is forced inspiration it goes to the minus 80 mm in the Mulliver's maneuver. That is when the person inhales with the closed mouth and nostrils plugged in. So when the nostrils are open and mouth is closed, in such way the lungs collapse, the airway collapse. So it is during Mulliver's maneuver. Now during expiration in quiet breathing, the normal breathing, the elastic recoil of the lung causes the intrapulmonary pressure to swing slightly to positive side, that is minus 1 mmHg, which forces the 500 ml of inspired air out of the lung during 2 to 3 seconds of expiration. So now here the process will be reciprocal to the inspiration. Why? Because as we have seen that during the minus 1 mmHg, we take the 500 ml air inside. Same, during the expiration it is inspired out. Getting? And at the end expiration, once again the alveolar pressure remains 0 mmHg. As we have seen here, again it becomes 0 mmHg as it goes down. And forceful expiration against the closed gate, that is Valsova's maneuver, may produce the intrapulmonary pressure of as much as 100 mmHg. What is this Valsova's maneuver? When the person exhale, that is expire, with the nostrils and mouth and glottis is closed, this increases the pressure. So forced expiration, it is Valsova's maneuver, which is opposite of forced inspiration, that is Muller's maneuver. Do remember the difference between both, that in Valsova's maneuver, nostrils and mouth or glottis is closed and the person is exhaling, and in the Muller's maneuver, mouth is closed and nostrils is open and the person is inhaling. And in that minus 80 mmHg, and here plus 100 mm of Hg. Clear? Now we will see intrapleural changes during respiratory cycle. Pleural pressure is the pressure of fluid inside the space between visceral pleura and parietal pleura. Both the pleura is there, in between which the fluid is there, it is pleural pressure. Normal pleural pressure when the expiratory muscles are completely released airway are about minus 2.5 mmHg. We can see here, where the normal pressure in the inspiration is minus 2.5 mm of Hg. How much? Minus 2.5 mm of Hg. That is normal intrapleural pressure. Now the negative pleural pressure is the amount of suction required to hold the lungs at the equilibrial volume or the functional residual capacity FRC. Because why minus 2.5 mm of Hg is required? Because it is a negative pleural pressure to maintain the equilibrium between lung and the atmospheric pressure. Because if both will be same, then it will be the reason of collapse of lungs. And FRC is the lung volume at the end of normal or relaxed expiration is about 2 to 2.5 liter of gas. So negative pulmonary pressure is what? Basically when the diaphragm contracts and move down and the intercostal muscles contract and move up and out, and this causes the lungs to expand, lungs expansion. So it is negative pleural pressure, because during the succession of air inside the lungs need to be expand. The negative pleural pressure minus 2.5 mmHg is the result of balance of two opposite forces, as I told, the recoil tendency of lungs and the recoil tendency of thoracic cage. Now we will discuss one by one. First is recoil tendency of lungs, that is continuous tendency to collapse. This is the collapsing tendency of lungs. So the presence of many elastic fibers in the alveolar walls which are under constant stretch is in the inflated lung. So when the lungs is inflated, the fibers which is present on the alveolar walls rapidly stretches, due to which it leads to collapse, because stretching leads to collapse. Surface tension of the fluid lining the alveoli, due to which the alveoli tend to become progressively smaller and collapse. As the surface tension will decrease in alveoli, it will lead to the smaller alveoli and hence collapse. Now we will discuss recoil tendency of thoracic cage, that is the constant tendency to expand, to poop outward. This will be the expansion tendency of thoracic cage. And if the thoracic cage is expanding, then the ultimately lungs or chest wall will be responsible. It's because that the fact chest wall is an elastic structure which is normally partially pulled inward. As the chest wall is pulled inward, and the elastic property of thoracic cage is because of the elastic nature of ribs, muscle and tendons. As it is pulled inward, the ribs, muscle and tendon which is present on the diaphragm and the other muscle pulls this chest wall upper side. So as this thoracic cage moves, as the chest wall moves inward, the thoracic cage moves outward due to the presence of ribs, muscles and tendons because both work simultaneously. So it is written that the thoracic cage is put outward because of the inversion of chest wall, because the chest wall is pulled inward. Now during inspiration, due to expansion of chest wall, the pleural pressure becomes still more negative, that is minus 6 mm Hg, and pulls the surface with the greater force, creating negative intrapulmonary pressure. As inspiration is there, due to expansion of chest wall, is called minus 6 mm Hg of negative intrapulmonary pressure, which you can see here. As it is pulled till inspiration, now it will create the minus 6 mm of Hg, you can see, and hence the intrapulmonary pressure will increase. So intrapulmonary pressure is directly proportional to intrapleural pressure. During expiration, at the end inspiration, that is the process of starting of expiration, the inspiratory muscle relax and the recoiling force of lung, that is collapsing of lung, becomes pulls the chest wall back to the expiratory position. As the inspiration is going to end and the expiration is going to start, at end expiratory position, when the recoil force of lungs and the recoil force of thoracic cage balances, the pleural returns back to minus 2.5 mm of Hg. So it again returns to minus 2.5 during end expiration. As you can see here, it's minus 2 mm of Hg, then here it is plus 2 mm of Hg. So both are reciprocal and vice versa. Now factors affecting pleural pressure. First is deep inspiration. The pleural pressure may become as low as minus 30 mm Hg during deep inspiration. When the person is inhaling deep, it can lead to minus 30 mm Hg. Valsalva maneuver, when expiratory muscles are working against closed glottis, there occurred marked decrease in thoracic volume, causing deflection of lungs. So when in the Valsalva value, we will see that it is due to closing of glottis, and it leads to the deflation means when the diaphragm relaxes upward, pushing your lungs. At that time the deflection occurs, when the diaphragm pushes your lungs upward. And under such circumstances, the intrapleural pressure can be positive by 60 to 70 mm greater than the atmospheric pressure. Example, during defecation and coughing, that is process of passing stool, defecation. At that time this can become greater than the atmospheric pressure. Now gravity. The pleural pressure is the standing position is more negative, minus 7 mm Hg at the apices of the lung as compared to base. Now during the apices of the lung, the pleural pressure is more, that is minus 7 mm of Hg compared to the bases, where minus 2 mm of Hg. Because of this fact, lungs are less expanded at the base. Even the airways at the base may become closed at the end of inspiration. So base lungs does not expand when. This is the why first part of inspiration, more of the inspired air goes to the apices of the lung due to minus 7 mm of Hg. What is the apices of the lungs? Which is present above the level of first rib, apex. It is also known as apex pulmonis. Like this way we have observed now, clavicle is there, and here the portion of lung starts. So this portion, which I have marked red one, this is apices of lung, and which I have marked yellow one, it is bases of lungs. Getting? Now injury to chest wall causing pleural cavity to exterior causes air enter the pleural cavity, that is pneumothorax. When the air enter in the pleural cavity during injury, and then the pleural pressure rises from subatmospheric level to atmospheric level. Subatmospheric level is level greater than the atmosphere, and since there is no opposing force to elastic recoil of the lungs, so pneumothorax of the lung is collapsed, because subatmospheric pressure reaches to atmospheric pressure. So in the atmosphere and in the lungs, both are equal. Both the pressure are equal on the lung side and atmosphere side, and hence it leads to collapsing of lungs. Now emphysema is a disease of the lungs in which the lung elasticity is decreased or lost due to decrease in recoiling force of lung. The intrapulmonary pressure becomes less negative, that is increases. Now it is when the lung loses the elasticity, intrapulmonary pressure becomes more or less, as the lungs don't have more capacity, it becomes more negatively, which simultaneously increases. And because of this reason, in this disease, the lung alveoli expand and chest also expand both and becomes barrel shaped. So lung and alveoli become barrel shaped. Now measurement of pleural pressure. Manometric measurement can be made by inserting a needle into intrapulmonary space whose other end is attached to a water manometer with the help of rubber tubing. So with the help of rubber tubing, where the needle is inserted in the intrapleural spaces between two pleura, and the pressure can be measured. Another is intraesophageal pressure can be recorded with the help of an air containing rubber balloon sealed over a catheter. So catheter is placed on the rubber sealed in the lower part of the thoracic part of esophagus. And intraesophageal pressure in the thoracic part is equivalent to the intrapleural pressure because this part of esophagus becomes closed due to closure of its lower end by cardiac sphincter and upper end by closure of glottis. And this is the reason behind intraesophageal pressure, because intraesophageal pressure is equal to intrapulmonary pressure. And as the esophagus, as the intrapulmonary pressure in the esophagus becomes more lowered by the cardiac sphincter and upper end of glottis, and due to this both pressure becomes equivalent, and this can help you to record the it because two sphincter are present, one is cardiac sphincter and one is glottis. Now lung volume during respiratory cycle. During tidal inspiration, the volume of air in the lung increases by 500 tidal volume. During tidal expiration, the elastic forces compress the lungs, that is outflow of air in the lungs, which starts flowing out, and the end expiration the volume decreases by 500 ml. We have already seen this in our diagram where it decreases by from 500 it again decreases. So it was all about, and it can increase and decrease, do remember, okay? This is about the pressure and volume changes. So it is plus 2 mmHg. Here it is minus 2 mmHg. Both increases and decreases, vice versa. So the graph is plotting like this, where here it is minus 2, here it is plus 2. So it was all about today. Here the lecture is ended. In case of doubt, you can ask in the comment section. Okay, and we will be continuing the next topic soon, and keep watching the videos and keep revising the earlier portion.